Okay, so we're going to explore the rational function using Desmos to see how we can look at different properties of these rational functions. So we're going to look at functions up to 3 degrees. So we got 1 over x, which I plotted over here, and I used a slider so I can look at different graphs of this function when it's at a different degree. So now we can just look at the degree 1. I put in the parent function here, so we can always see what the function looks like without the degree, or without any changing to the variables. And I put the sliders in so we can see how the graph changes. So with the vertical asymptote, I have a slider here as well, so I can line it up and kind of see. And I can move these values to see how it changes. So we can obviously tell that the B is what changes this vertical asymptote. So if we put B at 1, our vertical asymptote is 1, and A just changes about that vertical asymptote. So I also have a horizontal line in here for a horizontal asymptote. So I put it at 0, and I can move A. And it also just moves about that line as it did in the previous slide. And we can see that B also does not change it. And I also have that parent function in there. For the y-intercepts, we can also just change the sliders just to see how the graph moves. Same for increasing and decreasing. We can move the sliders to see how it changes the direction of the function. So now we're going to look at the 1 over x squared. So we have the parent function in here again, just to see what it looks like. And we can change our sliders. So the vertical asymptote, I have it right down the middle pretty much at 0. So we can tell that that's not a vertical asymptote there. You can move it over. Can't really get it right here, but if we move A, then we can just move our sliders to see how the graph changes, and we can notice that we will need 2 vertical asymptotes. So for the horizontal, I also have a line in there. We can just put it at y equals 0, which is how most of these graphs behave. And just play with the sliders just to be sure that it never crosses it, just switches its side. Same with the y-intercept, just like the other one. You just play with the sliders just to notice that how it intersects each point. Same with increasing and decreasing. Just play with the sliders and notice how it changes directions, and how the upside down parabola or the regular parabola, depending upon what your A value is, changes using B and A, and how that affects the increase and decrease in values. So of the 3rd degree, once again I have the sliders. And these are really helpful to notice this little change in the graph by just changing the slider. You can see how it changes sides with B, how it moves up and down with A. With the vertical asymptote at x equals 1, notice it just switches sides because B is also at 1, so that's what our horizontal asymptote is. Just change with A and change with B. Notice that you have to change the asymptote. Same with the vertical. I got it at 1, but I'm going to put it at 0. Change the A, just switches the sides. With B, just moves the graph from right to left. The y-intercepts, So you can just play with the sliders and move them around and just notice how it intersects the graph, or how it changes direction, or what values correlate with the horizontal vertical asymptote, so you can help find a value for that. And that was my Desmos vertical properties of rational functions.